Welcome to part 2 of this series of interviews discussing transitioning to IP with industry experts. I'll be talking about the challenges, the decisions made, and the long-term thinking. Geir Borderland is Head of Technology Portfolio for the Norwegian Broadcasting Corporation and is building a greenfield site. Paul Markham's Director of Media Infrastructure Architecture Software at Discovery. And Dave Schwartz is Managing Engineer at Diversified. Once we've made the decision to transition to IP, there are a whole load of other decisions that need making as well, and the primary one being what type of topology to use. But the beauty of IP is that it is constantly expanding in terms of its speed and its productivity. And we don't have to make all the decisions right here, right now, and right today. With our experience of SDI and AS and analog, we often had to think many years ahead, 5 or even 10 years ahead, about the type of infrastructure we would need. With IP, that's quite different because we only have to think in the short term in terms of the infrastructure we'll need because we can always expand later on. Paul Markham talks about the minimum viable products in terms of software, but also how this can be applied to hardware too. And this has a great resonance for IP. Microservices are quite interesting for broadcasters because they allow us to think completely differently about software. And Geir has some very interesting views on microservices. But I start by asking Geir about his considerations for latency.
And I'm a sound engineer from background myself. And of course, when I'm sitting here with some earphones and you know the situation in a radio studio that if you run an audio signal down to the central and if you place that central in Amsterdam for Norway, you will start already getting some big issues about latency if you run that signal back to your headphones again. Because I think as a journalist also from background here, if you have anything more than a millisecond into your speakers, you will start getting some big issues here. But so we already seen that when we set up we have some small installations for radio. And we've seen that you have to bring in a package inside the studio that keeps some DSP functions and also some functions for speakers and microphones and so on, and also for ingest of audio signals, very local. That probably will be under the table of the audio installations there. Then, of course, you could bring a lot of things down to either a private data center somewhere in the same city or inside the same country. And of course, you could utilize the big multi-cloud vendors somewhere, either if they have installations for us in Norway or other places in Europe. So, but what I think will be wise is that you have to limit the numbers of vendors and especially limit the integration, so you're sending the signal back and forth in between different systems. In fact, we've already seen that in other sectors also, that it's wise to not send off the signals back and forth in between Oslo and Amsterdam or Oslo and Ireland all the time, and trying to keep it kind of the same environment. And this is going to be a big discussion with, for example, routines like transcoding, all kind of DSP and handshaking in between different processes or microservices and different service parts here also. So kind of limit the latency in total. Then of course sync and the PRP and the sync system within, for example, 2110 is going to be a real crucial part here to get everything hooked up together again, because now you're going asynchronous out into the world here, and we have to sync it up again.
Yeah. And what are those challenges do you think you'll face with the synchronization? I mean, I'm assuming you're going to be using PTP.
Yeah.
So how would you see that working? Will you have multiple grandmasters in different areas? I mean, how will that work?
Way too early for us to check. We are using PTP already in our infrastructure today, but I think here it's what's crucial here is that we get all the new standards within 2110 really to work. And I know that it still are some work to do here in the standardization. I'm following the I don't know if you've seen the pyramid from EBU, where they track all the different standards within 2110, and it's still fairly red in the bottom. But I think at least way before we are going for a new building, we will probably see a lot more stable package in the standards there. That's what I hope for.
We hear a lot about microservices. Could you tell me how you're planning to use these?
We're doing a lot of microservices today with our metadata systems. We run a big project in NRK that ended about 2 years ago that we called Origo. Origo was a way to build the metadata systems from production or really from ingest and all the way up to publishing in a new way. So we built a new metadata structure we call the metadata bank, which is based on a semantic web surface and with a lot of microservices on top, and also a specialized tool we call Potion and the radio archive that we could search into the television part and also into the radio part. And that's really have done a great job to making it much easier to find all the materials within our, well, close to now 4 million clips from radio and television. And the difficult part in a radio and television station now is really finding all the material. And you know, I could think about another company that has done a great job figuring out how to search with one line, and that's kind of the things we try to copy with Potion, really to being able to search for things with one line, but also keeping a lot of advanced functionality under the hood that's kind of a little bit not visible for the journalists, but that they could utilize when they need it. So we are in the last stage now of implementing this in our television infrastructure, and radio was finished about 3 years ago. So we have done a big change there already in that respect, and microservices has really been one of the crucial parts of this.
Okay, so why would you use microservices instead of just a big piece of software? What advantages are they bringing?
That kind of makes it much more modular. And we started with Docker in kind of the middle of this, with with the Dockerization that, and Kubernetes really came as a good build-up on top of that. And at least that's what our software developers has told me in this. Of course, also development has really started to build a lot of stuff. So we still have a lot of services that we are building ourselves. A lot of them are built on top of open source functions and microservices. And now we also started moving a lot of this into a more multi-cloud environment, like, for example, Microsoft Azure, and into the different Google services and Google Cloud.
It's clear that we're only just scratching the surface of the decisions that Geir and his team need to make. But to me, this reinforces the power of IP, because IP is constantly evolving, is constantly innovating. There are many industries piling massive amounts of R&D resource into improving its speed and improving its latency. And to me, this is a massive bonus for broadcasters, because we can buy state-of-the-art equipment as and when we need it. Software is playing an increasingly dominant role, an important role in real-time signal processing for audio and video. And by its very nature, software encourages flexibility and scalability. But with this new way of working, we also have to have some new working practices, and the most dominant of these is Agile. Agile has been around for many years, and it's been used extensively in other industries, but it's relatively new to broadcasting. And I had the opportunity to discuss this with Paul and talk about how Agile can be used in broadcasting. And it amazes me, it's not just about software, but it's also about hardware too. But one of the greatest changes we've seen in recent years is that the innovation that software development brings is being driven by the business. So for many years, technology defined what the business could do because we were working at the speed of hardware design. But now we are working more with software. It's actually the business that is driving the business requirements. And I asked Paul if he thought this was a fair assessment. And do you think this is where the power of agile development comes along? Because again, that's not just about writing code, is it? It's about writing code in a very fixed way and delivering for the business.
Yeah, I mean, I think agile development is often misunderstood. I think it's a philosophy, and then there are specific methodologies such as Scrum or Kanban maybe that come with agile development. I think it's easy to sort of look at this word agile and kind of be a bit cynical about it, isn't it? It's easy to sort of look at it and say, oh well, that's something that startups do that doesn't really apply to what we're doing. And I think let's not beat around the bush in terms of saying it doesn't apply to everyone, to every situation, but like I was saying, really, with the idea that there is an industry there. There's an industry there, and they've come up with agile, and the software development industry has come up with agile and the various specific methodologies within agile to solve problems that I think every software development will have. And I think you have to look at agile as a very serious set of tools if you're serious about developing software. And that's not to say that it's suitable for everything, but I think what you can't do is sort of dismiss it and say, well, that doesn't apply to our industry, or that doesn't apply to what we need to do, or doesn't apply to the way we work, or however you want to frame it. I don't think it's quite like that. I think it's something that once you're into serious software development, you have to embrace. And it's not, I think the other thing that's misunderstood about agile is that it's not just for developers. It's really an end-to-end project mindset that you have to embrace to make a success of agile, because there's no point in the developers being agile if they're still being held to fixed budgets and immovable scopes and basically a waterfall timeline. It's not going to be very successful. And I think we've all seen those big software projects that have struggled to live in both worlds. And actually, agile does provide a way to tackle those real challenges with developing software around that evolutionary scope. And I think we've all seen it. I think your opinion of what your software needs to do, what you need from your software, changes as your software grows. I think if you've been involved with any kind of software development, as soon as you see something, as soon as you see a version of whatever platform it is, you go, oh well, this is great, but I want it to do this, or I want it to do that. And suddenly your view on how it works does change as soon as you start engaging with something. And agile is really a way to codify that and to say, accept that that's how it is. You can't set in stone everything up front and walk away and hope it turns up 2 years later, because we know that software doesn't develop successfully like that. That those projects that have tried to develop software like that have been absolute disasters. So I think there's a lot to embrace there, in terms of there are a lot of solutions to problems that everyone will encounter, and it's always good to understand who's been there already and who's already walked this walk, and who knows what those challenges are and what the solutions that they come up with. Not to say those solutions are perfect, but once you understand what they're there for, I think you're in a much better place for tackling those challenges yourself.
Yeah. And some of the aspects of Agile I really like. One, it's so adaptable because, as you said, it's not just about software. It's about how a business thinks. Second, the sprints, because the idea is you deliver features every week or two, depending on how long your sprint is. And then there's a minimum viable product, which I think you touched on a few moments ago. It's get something in front of the users quickly so that they can see what it is they want and what they don't want. Yeah. Would you agree?
Yeah, absolutely. And I think we tend to think about, and again, this is all tied into the idea that if you're thinking about a hardware build, you think about all the things that you might want. And I think you've almost got to invert your mindset for thinking about a software build, because when you think about a software build, you've got to think about the only thing, the first thing that you want, the thing that makes it the basic viable, that minimum viable product. And do that first, and then put it in front of people. then get your feedback and develop it, build it outwards. So it's inverting the mindset and thinking in terms of how much, how little can we do, how little can we deliver, rather than how much do we need. And then, you know, when you've started to build from that small kernel and you expand both in terms of features and in capability and scaling, then you do build a successful product if you've got that user feedback loop continually going on. And yeah, this is, I suppose, on the other thing, you've really got to start talking to end users, because you can no longer make those assumptions about what what a component is or what it does. And I suppose one of the things about buying bits of hardware is that if you've got a bit of hardware that's, say, an SDI in and an SDI out, and it does something in the middle, there's not much, there's no complexity there in conceptually. You can put a label on the front and you can say, this is what it does. You stick this in here and take that out there. It's a black box and it does its job.
Yeah.
I think when you start talking about software, it's never that simple, and it'll never do what people expect it to do if you don't really focus in on what their needs are.
Yeah.
And that can be all the way from resource needs to user interface needs to cost needs to scaling needs and networking needs, all of those things, and resilience and reliability and what platforms it's going to run on. And there's so much to get right when you're producing a software appliance, as it were.
It's clear that agile development is a massive force for broadcasters and something they can benefit from greatly. And as Paul said, scope creep is one of the major dangers of any projects, and I'm sure we've all experienced that. It can be responsible for projects massively overrunning and for blowing budgets. But Agile, with its MVP type approach and its short-term sprints, and actually getting product out there to users so they can try them at the earliest opportunity, helps alleviate these problems. Monolithic and leaf spine switches are just two of the architectures used for broadcast facilities when using IP. But that's only part of the story. I mean, we also need to think about latencies, we need to think about bandwidth allocations, we need to think about blocking and non-blocking. And there's a lot more to designing the topology of a network than just deciding which kind of switch and architecture we're going to use. I had the opportunity to discuss this in great depth with Dave, and I started by asking him about monolith switches and how broadcasters get their heads around these different types of architectures.
Monolith is inherent, with the right choice of switches, is inherently the same as if you build your entire SDI facility around a single router, and that is a non-blocking thing. A monolithic system is in IP is the same thing. If you build it around a monolithic core, then it is effectively the same thing as that one giant router in the core. Mm-hmm. But if you're building out something that will have sub routers in the SDI type environment, then that automatically says you want to go into a leaf spine architecture, and now you can discuss whether that leaf spine architecture truly needs to be non-blocking. Mm. Now, to your point, do people get their heads around this? I built my first IP facility 7 years ago, and it took me a good few years to wrap my head around it. So I don't expect people to jump on this. It took a few facilities before I had the eureka moment. Now, I've spoken to several people about it, and actually right now, I can't really discuss the client, but I'm building my first IP-based blocking facility because it made sense for the client, and this took some discussion.
I mean, I'm just thinking of the scenario with a camera. So one of the big advantages of IP is that a camera which may have multiple video outputs, video inputs for the teleprompter and the reverse vision for the monitoring feeds and the intercom and the tally and all of the other services the camera provides. Instead of having multiple cables from the CCU, we can now just have one fiber, one IP fiber. And in a scenario where that would go into, say, the leaf in a leaf spine, and you had multiple cameras, the natural assumption would be that all of those feeds have to go to and from the core switch. Do you think that's a valid assumption?
Well, in most facilities, yes.
Yeah.
They're ultimately going to have to reach the core switch, but they don't need to be connected directly to it. You have to look at your points of use. Where you gain efficiencies are things like putting the vision mixer and your multi-viewer on the same leaf switch, because 90% of what feeds your multi-viewer also feeds your vision mixer and vice versa. So all you need to do in terms of bandwidth management, you need to get those multicasts. Even though it's going to two different destinations, that multicast only needs to get to the leaf switch once, and then the leaf switch will distribute it to multiple places. So if you can put those devices, as an example, on the same switches, you minimize the bandwidth that you require. Now, you still want to, again, you want to design with a lot of overhead. You want to be able to plug something else into that switch without breaking something. So you never do it tight to the numbers. Frankly, I always make sure I have at least 50 gigs left over, because, that gives you plenty of headroom, even if you're doing 4K. Now, your example of the camera, if the camera is on the same leaf switch as your vision mixers and your multi-viewers, then unless you're recording an ISO of that camera someplace else and that ISO recorder is on a different leaf switch, that camera stream, its main picture stream is not going to need to go back to the core. However, there are streams within that are going to need to go back to the core. The monitor feed with the on-screen display that the shader is going to want to look at. Unless your shader is on the same switch, the only way you do, if you have the multi-viewer as the switcher and the shader on the same switch, you're talking about a monolith. But let's assume they're not on the same switch. You've got stuff that's got to go back. Your intercom is probably not on the same switch. All that audio has got to come back in. But there are big, you can't make it so that everything's on the same switch. You can optimize, but you can't minimize. Minimize was a bad term I used before. You can optimize.
Right. Okay.
And the whole idea of putting all those things on a single connection, well, first of all, those connections are redundant in most of the systems we build, using a 2022-7 redundancy. And secondly, it reduces your cost of installation significantly. I mean, it's literally plug a fiber into an SFP rather than building the breakout panels for the DB37 that the intercom and tally is on the back of the camera. It's a lot of man hours saved.
And where do you think we need to use blocking switches instead of non-blocking?
So where we can use blocking, and I emphasize it's not appropriate for every facility, but where we can use blocking, it's really about going back to the managed tie lines environment where we were in SDI. Where we can use it, you save on optics, SFPs, QSFPs, you save on fiber trunks, you save on ports on your core switch. Your core switch may be able to have fewer line cards in it or just be a smaller switch, and still have enough bandwidth to do everything you need.
I think it's fair to say there isn't just one way of doing things. But what do you think we really need to think about?
The broadcast idiom of, point-to-point connection. If I need to send you an email, Tony, I do not take my laptop over to your laptop and set up a crossover cable between them. That's almost what we were doing in SDI.
Yeah.
We all use networks this way all the time for things other than video and audio essence.
Mm.
It's just a matter of doing a thought shift to how best to use what we're already using for that essence.
As far as formats are concerned, are you still seeing people using SD2022-6, or has 2110 now taken over?
2110 has pretty much taken over. The fundamental differences between them is 2022-6 is like an SDI signal with embedded audio and the closed captioning and other metadata in the VANC and HANC, and it's all in one package, unseparable. 2110 goes back to the old days when we had a video router and an audio router. They're separate multicast streams. And for a production environment, it makes much more sense. You don't need to move a 3 gigabit stream to an audio mixer to recover 1 megabit worth of audio. So again, this streamlines your network. It takes out a lot of the overhead. 2022-6 still has a place in that everything is moved as one package if you need that. Moving stuff out to, doing distance transmission, that has advantages. Now, distance transmission has moved into a compressed environment because, some of the new codecs are so good they're truly visually lossless. So occasionally I run into a good application for 2022-6, but it's more and more limited. In the production environment, 2110 is much better suited, which is one of the reasons it was developed. And in the long haul environment, compression has 2022-6 is an uncompressed format. People don't generally want to spend the money on the bandwidth to move uncompressed signals. But if you did have to move uncompressed signals distance, that's a good way to do it.
Something we must remember about IP is that there are many ways to solve particular problems, but to truly leverage its power, we must start thinking in dynamic terms. And this was most evident to me when Dave mentioned blocking architectures. On occasion, he said they could be used. They do have their place, and we shouldn't always think in terms of non-blocking architectures. And I'm sure that's not something you will read in the textbooks. But careful system planning at a very early stage could help save massive amounts of money as the project progresses. In part 2, we looked at the infrastructure topologies, not only in hardware but in software too. IP is driving the adoption of software for real-time video and audio signal processing, which further improves scalability and flexibility. In the final part of this series, I'll be discussing with Gear, Paul, and Dave the operational aspects of making IP infrastructures work and making them incredibly reliable.